Welcome to the class on artificial neural networks and reinforcement learning. In this lecture series, we look at reinforcement learning, TD learning, and SARSA. And in this first video, I start with presenting a couple of examples of reward-based learning. Most neural network classes focus on networks for classification. You put in an input image and you want an output. And some cases it's a car, in other cases it's a dog. And for the training in these situations, what you need is a training base, a database that has for each input x mu, a target output t mu, and this target output comes from a teacher or supervisor that has previously looked at the database and assigned correct labels. And the question now is this realistic? And my answer is no. In reality, it's very, very rare that you have a labeled database. There are a few exceptions. For example, if you think of predicting the next frame of the video, well, you have long sequences of movies that takes hours at a frame rate of 20 per second or so. So you have lots of data, and the frame at time t can be the input and the frame at time t plus 1 can be the output that you want to predict. So that's one example where you have labeled data, in which case this labeled data would be very high dimensional. Now, there is one other situation where you have it, and that's predicting the output of the same, predicting output that's the same as the input. That is called autoencoder. However, in most scenarios in the real world, we are not in this situation. Think of a table tennis player that learns a new serve. I don't think that the teacher, the trainer, takes the arm of the player and shows him or her every movement. Same for the piano teacher. The boy plays a piece and afterwards the piano teacher says good or bad at this location. But he doesn't take the arm. There's no detailed supervised signal. So where's the supervisor in these cases? Nowhere. The feedback is a coarse feedback, a rare feedback, a sparse feedback. There's no labeled data. If you want to train a dog, well, what do? You give reward at appropriate moments. So there is not this target value from which you can derive a very precise, detailed feedback signal, but there's a very sparse feedback that says this was good, this was bad. You can give a reward in the form of a goodie for the dog, but it's not a detailed feedback. And then the question is, can we learn on such sparse feedback? If you look at what neuroscientists tell us, there is a system deep in the brain that also sends out axons, these long cables that go all over the brain. And this signal that these neurons send out from deep in the brain is a success signal in the sense of reward minus expected reward. And that's sort of exactly what you need if you want to learn based on rewards. The specific neuromodulator is dopamine. This is one of the 4 or 5 major neuromodulator systems in the brain. I believe that animals learn basically based on reward. So you put some animal into an arena, it starts to walk around, and maybe it finds at some location a food source. You take it out, the next day you put it back through a different entrance, and it goes straight to the food source. That's invisible, that's hidden under the sand. So how does it do it? Well, the food is a reward. It learns based on reward. Here's how these experiments are done with animals. You put a rat or a mouse into a pool, a tank of cold water. There is one platform, but it's not visible because this platform here is embedded into milky water. Now the water is cold. Rats or mice don't like cold water. They try to get out. The only way to get out is to approach this platform, and then they can get out of the cold water. Now in the first trial, it just takes a very long time to get out. This is the time to find the platform. It's just very long. But after a few trials, it basically goes straight to the platform, and you see this in this time called escape latency to reach the platform. It becomes much shorter after just 10 trials or even just 8 trials. So the mouse, the rat, learns quickly to find the hidden platform, and getting out of the cold water is a reward for this mouse or rat. Humans, when they play games, when they learn to play games, if you think about when is the feedback signal, when is the reward? The reward in chess is at the very end if you have won. The reward in Go is at the very end if you have won. So human players have to learn based on these moments of reward. Now, recent developments in deep reinforcement learning have shown that indeed deep artificial neural networks can learn to play games like chess or games like Go, and you represent the current position in the input. You use a network to learn the actions. You learn the actions. That's the network for choosing the actions. And the way you do it is you have a second output unit, and this output unit learns to encode, to represent the value of the current position. And based on this value, you can derive a success signal, and this success signal is reward minus expected reward. So learning happens driven by the success signal. As in normal artificial networks, learning changes the connections. The aim is for the action network to adjust the weights of the network so that you win. And the aim for the value unit is to predict the value of the current position. And then you train and you learn. And the same kind of principles have also been applied to the set of computer games, the old Atari games. And in the mini project of this class, you will also use this kind of reinforcement learning to solve some interesting tasks, such as playing an Atari game, landing on the moon in some simulator, staying on the road in some car, or something like this. Let's sum up with a little quiz. Please stop the video so that you are prepared when we go through it. And now let's go through it. So reinforcement learning is based on reward. Well, that's true. Reinforcement learning aims at optimal action choices. Well, that's true. In chess, the player gets an external reward after every move. Well, that's not true. The external reward comes at the very end. In table tennis, the player gets a reward when he makes a point. And yes, this is true. A dog can learn to do tricks if you give it rewards at appropriate moments, and this is obviously also true.